Hello friends, welcome back. Today we will see some latest Java features. Okay, so most of the Java developers are still writing Java 8 style code, but Java 21 has completely changed how we write the backend applications. So in this video, I will show you modern Java features from 17 to 25 with some real world example, not theory. Okay. So first of all, we will see sealed classes. Okay, what are the sealed classes and interfaces with all scenario? So sealed classes are introduced in Java 17, and okay, those are actually basically used to uh, restrict the child classes to get inherited from it. Okay, so we will see step by step. Okay, so we will go to this package first, and let's say we have one parent there. We have one parent there, and parent is having some wealth. Okay, uh, string wealth. Okay, so parent is having some string wealth. This method. Okay, and it is returning wealth. Okay, so we can say parent is have some wealth. Okay, and this parent only want to share their wealth with their child and their daughter, and not any stranger. Okay, so we can add public sealed class parent. As soon as we add that, it is showing that sealed class must have the subclasses. Okay, so it is the rule that when as soon as we declare our class as sealed, then it should have child classes. Otherwise, if it there is no point to declare at sealed, right? So let's create child class. Okay, so let's say this is son. This is very real world example. Okay, and which is extends parent. Perfect. So okay, so what it is showing, this son is not allowed in the sealed hierarchy. Okay, which means that we need to allow it. Okay, so there is one option permits, and here we need to write for which classes this parent is sharing their wealth. Perfect. So all sealed class subclasses must either be final, sealed, or non-sealed. Okay. So we are saying that this parent will share their wealth to their son. Okay. But this son also there is rule. This son should also be either final, sealed, or non-sealed. Okay. So let's say son is final, and finally we are going to public final class. Okay, and we are going to uh, share parent are going to share their wealth to their son, and that son is final. Okay, means let's say grandsons are not there. Okay, grandchildren are not there to this son, for example. Okay, and okay, let's say grandchildren are there, grandchildrens are there. Then we can add sealed also. As soon as we add the sealed, then we need to mention here which are the grandsons are there. So let's say grandson, grandson is there, and which is extending son, extend son, and let's say grandson is having no more childs, and let's say it is the final one. Okay, and now son need to also permits it. Okay, son also need to permits it because this is sealed class. Okay, so till this point is okay. So now let's say their only parent only want to share their will to their son. Okay, and not to the stranger. So let's say here some stranger comes, new class. This is stranger and it is outside of the family. And when it is trying to access extends parent, then it will be not allowed. Okay, what error you will get? See, stranger is not allowed in the sealed hierarchy. So in order to allow for that sealed hierarchy, you must need to permit it. Okay, sealed class permit clause must contain all subclasses. Okay, so the stranger is not allowed. Perfect. Not allowed. Okay, so let's comment it out. Okay, so now let's say seal demo. Seal demo is the class where we will create main method, and here we will add parent parent equal to new son. Okay, and parent dot wealth. Okay, and parent dot wealth, son is using parent parent wealth. Perfect. Only son is allowed to use the parent wealth. Okay, so we got the output, son is using parent wealth. So that is the main agenda for the seal class. After public, add seal keyword. Okay, what are the role? So let's say after public, add the seal keyword. We have added it. Then seal class must have subclasses. Okay, seal class must have subclasses. So we created son subclass, right? You cannot just define the seal class and forget it. Okay, so suppose we don't add any subclass, then there is no meaning of adding the sealed classes. Okay, when you create subclass a child, then child class should be either final, sealed or non-sealed. That we already saw, right? Imagine like some parent want to share their asset with only few peoples and not all, and way to restrict which classes can extend classes or interfaces. This brings more control to the coding. That's why we are adding sealed. Okay, so that is very straightforward. Okay, we already saw this example. Not allowed, stranger class cannot parent, not allowed to utilize the parent wealth, hence stranger class is not allowed. Perfect. Okay, we already saw this one. Then let's say we are seeing non-sealed. Okay, we have not seen non-sealed, so instead of this final we can add non-sealed also, which means that anyone can extend this grandson. Okay, anyone can extend this grandson. Okay, let's say stranger also can extend this grandson now. Uh, Stranger one, let's say, and the stranger one is extending grandson, and now he can access their wealth. Okay, grandson, grandson equal to new stranger one, and grandson is using grandson is using grandson wealth. Okay, or let's say stranger. Why we added this one? Because now they made that as non-sealed, right? The stranger one can able to access grandson because this is non-sealed, which means that anyone can extend and anyone can utilize their wealth. Okay, let's say. So stranger is utilizing grandson's wealth, okay? But their parent is not allowing to utilize, his wealth to their any other stranger. Okay. So this is fine, perfect. We already saw this one. And let's say then parent want to permit one more their daughter is there, okay? So let's say daughter daughter is there, and this daughter extends parent, and let's go to parent and add daughter also. Perfect. Now if we go to daughter, then this daughter can should be either final, sealed or non-sealed. Okay, let's say it's final. Daughter is final. Perfect. Now and daughter is accessing parent, parent one equal to new daughter. Daughter is accessing parent's wealth. Okay. See, daughter can use parent's wealth. So this is the first change introduced in Java 17. So that's why we saw this one as sealed classes. Let's check any other enhancements. Okay. Okay. What is the second enhancement made? Named class and instance main method. Means don't define a class. We will not define the class at all. If we see this one. So if we are able to see this code here, class is not written, right? Only the main method is written, and also public static void main string args. This is also not mandatory. Okay. So you can just write void main and write your code. That will run perfectly fine. You can define where also, or you can define string also. That is also perfectly fine. You can run this one. This is called as uh, named class. Named class and instance main method. This is called as instance main method. Okay. So public static void main, no need to write it. Okay. And also if you see class name is also we have not written anywhere. Okay. Don't define a class println instead of system.out.println. Yeah. So instead of this all system.out.println, we can import static and we can write that one also. So what are the rules? You should have Java 21 for this. So this features is introduced in uh, named class is introduced in Java 21. So you should have Java 21 in your class path. Let's say we have added Java 21, right? And yeah, that's it. Okay. So we saw this feature. So third feature, what is the third feature? Directly assign switch to a variable. Okay. If we see this third feature, switch. So before switch, how we were able to write the code? So let's say we have this main method. Let's say we have the status as failed, and we write the switch. Then we write the case if it is success. Then we assign some message equal to payment completed, and we were writing break statement. Again, we were opening switch for failed case. Then here we are updating the message as payment failed. Then we are writing break statement. Again, we are writing case if it is payment is pending, then we are saying payment is pending. In message we are assigning it, and again we are doing break. Then in default we were writing some default one. So this boilerplate code is there before enhancement. Okay. So too much boilerplate code is there and easy to forget break. So we can what if we forgot the break, then this both condition will get execute, right? So that is the problem here, and hard to maintain, very hard to maintain, right? So each and every case we need to write in number of boilerplate code. So what is the enhancement here? If we go here, then in enhancement, we can see we can add direct case. If case is success, then open arrow symbol and just write the message. Okay. No need to write the break statements. Okay. This is the very much good enhancement. Switch can return value also. The switch can is returning the value also, right? The message it is returning. So every time message equal to this, message equal to this, message equal to this, we no need to write. Okay. So instead of writing message equal to assigning message in every case, we can just return the message from this switch itself. Okay, that is the very good enhancement we have got. Okay. So real world example is role based access control, right? So let's say who is super admin and they will have full access. Who is admin, they will have full access. User will have some limited access. Okay. So in this way, if we run this one, so payment completed. Why payment completed we got? Because it is success case. This case success is matching here and it is returning payment completed. Also, one more thing is present here is if you don't want this arrow symbol, then you can use yield also. Okay, colon yield. This you need to write. But the rule is if you are writing yield, then for every statement you need to write the yield only. Okay, either arrow or either yield. Okay, but not both at the same time. Okay, and for default also colon yield you need to write. Perfectly fine, no compilation error, and run it again. Then your code will run perfectly fine. So switch can return a value. So if you see the switch is returning the value message and we are printing it, we can use it anywhere. No break. So let's say anywhere we have not added the break statement. Perfect. Clear syntax. Syntax is very clear, right? If case is success, then return this. If case is failed, then return payment failed. Okay. More readable business logic. So here business logic is more readable, right? Instead of this old way. Okay. So let's next check pattern matching. Next enhancement we got pattern matching. Okay, for this pattern matching, let's say in old way how we are doing pattern matching. Okay, so here we were writing instance of operator. Okay, let's say we have one object class, and any normal Java real world entity is an object, right? So this order object we created. One minute. This order object we created, and this order object we created, and here we created object obj equal to new order, and we are setting some order id and order amount. And here if we are checking if obj is instance of order, okay, then we are doing type casting. Order equal to in bracket order of object, and then from this order we are able to access id amount etc. So this explicit typecasting is needed in older way. But with pattern matching, let's say what enhancement we got in pattern matching. Okay. Okay. Let's say in pattern matching, we create the object obj equal to new order right order record. So this order record we created as record class. Okay. And here we are directly writing object instance of order record because it is record class, right? So we can use this for record class. Okay, so it is very straightforward. And here this one, right? Underscore we have given here. So why we given underscore here? Suppose we want to skip anything. No manual casting is needed. If record, then use Java to this smartly, right? Object instance of order record. So underscore are named pattern to ignore the values. Okay. Why we given underscore here? Because let's say we don't want order ID, right? We don't want order ID. Then we just want amount. Then we can ignore it. But if we want that order ID also if we want, then we can give it like uh, string ID. Perfect. And here we can write, we can print that one, right? We can create order ID and amount. Okay. If we don't want it, then we can just add underscore. But underscore is nothing but for ignoring that one. Okay. So let's comment it out and let's print only amount. We are ignoring order ID. Okay. So this underscore related thing is called as named pattern, which is disabled by default. You need to enable it using providing the JVM arguments minus minus enable preview. So minus minus enable preview, you need to write, okay, here we have written JVM arguments minus minus enable preview. Then only you will able to get this feature as enabled. By default it is disabled. Okay. So fifth enhancement is record class, that is immutable class. We already saw this record class, right? That is immutable class. Hash code, toString, getter, setter, etc. will be get generated automatically. So here everything will get generated automatically. Sixth enhancement is modern Java text box. Okay, let's close all these tabs. Okay, go to sixth enhancement. Okay, go to this. Before Java text block, what was there? Let's see. Let's say we want to create this JSON object, right? Then let's say how much slash n statement we need to write, how much slashes we need to write to just normal JSON string. We want just normal JSON string, right? But n number of things we are writing, like we are writing slashes, we are writing n number of slashes to just format a JSON. And what if we want to write any other very much complex JSON, then how much time it will take? Okay, so in order to resolve this issue, okay, let's run the and a second example is queries, right? Suppose we want to write some complex queries, then this plus conjunction, and everywhere we need to concatenate it with this string kind of objects. So that is also a messy thing. So let's run this. Before Java text blocks, how we were able to write this one using slashes and slash and all. Okay, but in Java text block, here see how much clean syntax is there, and we are opening these three blocks here. Okay, what we can say to this, okay, open three, close three, and inside that write whatever the JSON syntax you want to write. Similar is for queries and all. Okay, so this kind of clean structure we can add using Java text block. Okay, so JSON string introduced, this is introduced in Java 15, and before text block hard to review the queries slash JSON data, lot of slash n and slash where escape characters were there, right? So after Java text block, no escaping, just JSON we can add and easy to modify, right? it is very easy to modify, right? Suppose we want to add any address, okay, so we can add it like address colon let's say mm, India. So perfectly fine, just run this, and here we go, we got the address. So modifying is very easy, right? So now let's see a new enhancement, that is virtual threads, right? So this virtual thread, and go to virtual thread demo. So we will see before virtual thread how we were doing the things. Okay. So let's say this executor service is there, and here we are creating 5 threads. Okay. And we are, creating the object of this order processor, and we are processing the order. Okay. So if we want to use this virtual threads in Spring Boot, then in Spring Boot, you must need to add the property like spring dot threads dot virtual dot enabled equal to true. And that's it, right? Spring will automatically runs each request on a virtual thread. With virtual thread, you can make thousands of concurrent calls. Okay, they are ideal for IO bound workloads. These are the IO bound workloads, right? So let's say in order processor, what things we are doing? We are processing the payments, we are making the inventory, we are reserving the inventory, and then we are in repository, we are saving the order, and in notification service, we are sending the notification to send over the email or uh, any SMS text notification. Okay, and it is drastically reducing the thread management overhead once we uh, use virtual threads. Okay, what happens internally important. Okay, each order one thread is created. So here for any blocking IO operation, here blocking IO operation is there, right? So for blocking IO operation, it is very hard to use this virtual thread. Okay, but with virtual thread, what happens internally is each order one virtual thread will be created. So let's say this order processor is there. Here we are creating executor service, executor equal to executors dot new virtual thread per task executor. Okay. So every time a new thread will be get created, and you can use that one. Okay. So this is the basic syntax actually. And let's comment it out. And orders can run concurrently, not sequentially. Okay, concurrent order execution after virtual thread, run it, then we can see this output, right? Payment completed, inventory, payment completed, then inventory reserved, then order served, then notification sent. Okay, so each thing is happening in thread starvation mode. And no pool sizing, we are not giving any pool size right here. We are giving new thread, new virtual thread per task executor. Okay, so here we achieve high throughput, and JVM manages the scheduling efficiently, and OS thread is used. Okay, virtual thread is unmounted, and OS threads is used. Okay, so when the sleep is getting blocked, then OS thread will get used. Okay, so this is the very basic example of virtual threads. How we create the virtual thread. Executor service, executor equal to executors dot new virtual thread per task executor. Okay, in this way we create the virtual thread. We assign some threads, and executor dot submit. In submit, we are giving what is accepting submit method. If we go inside that, it is accepting runnable task. Okay, so here we are giving runnable task, and we are processing some orders. Okay, yeah, so these are some examples and enhancement in latest Java. Thank you for watching.